Hi everybody. So today I want to talk about the electric field. And the electric field is just a concept basically saying that like when we have a charge, it generates its own field around it that affects the things around it. So the formula for the electric field that you should know is this. So E denotes our electric field, and this is going to be our force over charge. And of course this is going to be electrostatic force. This is going to have units of newtons per coulomb because it's force over charge, right? But there's something I want to point out. Electric field has another formula that we can use, and this formula is given by. So if I have force, we know that the formula for force, and I'm going to explain why I'm doing it like this in a moment. So basically, if I have a charge, right, which will be given by like my Q, right, and I have a test charge, which basically says that like if I have if I put like a proton or an electron or something, right, or if I put like, let me say like a particle, right, within the electric field of like of another particle, right, that can be given by a test charge, right, that is going to be denoted as Q. So you would have seen this written as Q1 times Q2 times K over R squared, but this is sort of like the same thing basically, right? But they did this to be able to cancel this out. So basically, of course, like when we divide and multiply, right? We're multiplying by this. These two cancel out, right? So I get, I end up getting this for my electric field. So that's another formula that I can use for electric field. Same units and everything. I'm still gonna have newtons per meter squared. Newtons per coulomb. Another thing I also want to point out is like the convention that we use. So like let's say this is my positive and this is my negative, right? We have like electric we have like field lines. That's what they're called. I'll try and put these a little bit further apart. Basically, field lines just denote like what is going on with an electric field. We're gonna notice that when things are negative, the field lines are going in, because things always travel from positive to negative. And when things are positive, we have field lines going out. So it's like this. So those are field lines. We also should note that like the closer the field lines are, the stronger the force is from whatever particle we're dealing with, right? So if I took obviously like the field lines are a lot further apart here, right, than they are here. So that tells me that here will be stronger than here. And that's sort of like intuitive, right? The closer we are to like the source of an electric field, the stronger the electric field is gonna be. So that's what you need to know. Of course, like a neutron doesn't have like electric field lines going, because like it doesn't have positive or negative charge. That being said, you might have like questions that ask you like, oh, what the electric field would look like for, I don't know, like let me say I had like a bar magnet or something, right? And this is like, I'll do this side positive, this side negative, right? I would have maybe like things going like this, right? Things going like this. So just like it's always going positive to negative, like if that makes sense. So if things going negative always come in toward the negative, things going positive always go like away from the positive, if that makes sense. Or things coming like from a positive always go out of the positive. So again, if anything was unclear, please don't forget to like comment. I'll do my best to answer it hopefully. Please don't forget to like and subscribe, and let's keep learning, okay? Thanks.